Unit 5. Last time we used them. All right, ready to roll. Yesterday, I gave you the scale factor, give me the new coordinates. Well, here's what I'm going to start class off with today. I will give you the pre-image and the image, tell you it was a dilation, but now I want the scale factor. What did we dilate by? So if you look at the directions here, point R is the image of A. So I'm going from A to R. Oh, this is best news of today. Look where the center is. It's at the origin, which means I can use my shortcut. What did I multiply by? Because it's the origin, the center. So I can use the multiplication shortcut. What is the scale factor? All right, and I'm going to make sure we use the notation that was in the textbook last night of the scale factor being K. All right, so quickly, let's go through how I can find the scale factor. Since it's at the origin, we could say, hey, from 3 to 9, I had to multiply by a number. Because it was centered at the origin, I can use the multiplication shortcut. And that same number better get me from 4 to 12. All right, so I started out nice and easy for this one. So to go from 3, 4 to 9, 12, centered at the origin, I needed a scale factor of 2, Bailey, go ahead, sorry. 3, yep, no issues there. All right, scale factor of 3. All right, well, sometimes it's not that easy to figure out what the scale factor is. Multiply by 3. Take a look at 2 now. Now I'm going 9, 12 to 6, 8. So I got to figure out what do I multiply 9 by to get 6. Same value I multiply 12 by to get 8. And you don't need to guess and check here. If you're unsure, hey, set up a quick equation. Right? Set up a quick equation. Hey, I'm taking 9. I got to multiply it by the scale factor of K, and it should give me 6. Look at that. Pretty easy now. All right, set up a quick equation you can solve. 9 times this scale factor will give me 6. And I'm hoping we know what to do on both sides now. Because you guys know the scale factor is not always a whole number. Could also be a fraction. And what am I multiplying 9 by? And then what am I multiplying 12 by here to get 6 and 8? What's my scale factor on this end here, Stephanie? 2/3, good. And I like how Stephanie left it as a fraction. I'm not a big fan of 0.6666666. All right, make sure you go over those 3 dots on numworks and change it into a fraction. All right, everyone, all right? K equals 2/3 scale factor. All right, do it for 3 now. How do I go from -2 to -10? And then how do I go from -3 to -15? And if it doesn't come to you right away, set up an equation like we did in number 2 to find the scale factor. And that scale factor going to be 3. Stella? 5. All right, positive 5. Questions, comments, any concerns? All right, no big deal. Now, I gave you the points here. Now, let's find the scale factor just using the graph. All right, using the graph now. Please take your time and read the directions. Because I'm not going to, we have to figure out which one's the image here. Because that's going to matter what my scale factor is. Polygon B. Polygon B is the image. So polygon A is the pre-image. Ah, even better. Look at this. After a dilation at the origin. Yeah, because now we can use my shortcut. What did I multiply by? All right, so first, polygon B getting smaller or bigger in number 4? Smaller. So whoever I call in to give me the scale factor should be less than 1. All right, that scale factor you give me should be between 0 and 1 because polygon B's got smaller. All right, now, how can I find what that K value is? Turn this into the last 3 problems. What do I mean by turning it into the last 3 problems? Find a point on polygon A. You know, if you want to go here, that's what, 3, -3? And find its corresponding image on polygon B, which would be right here. And that's going to be 1, -1. Figure out what you multiplied by now. All right, figure out what you multiplied by. Now I just turned this into the problem we started with from today. How do I go from 3, -3 to 1, -1? What do I multiply by? And why can I say what I multiply by? Centered at the origin. And what am I ended up multiplying by here? Number less than 1 here, right? Number less than 1. Cormac? 1/3. Fuck, 1/3, yep. 1/3. Not 3. If anybody thought 3, that means you're getting bigger. We said polygon B was getting smaller, so that's why it's 1/3 versus +3. And then you and your group are on your own or on 5 and 6 right now. Go ahead. You got 5 and 6. So number 5, now you're getting bigger. So hopefully somebody's going to give me a scale factor that is bigger than 1 for number 5. Number 5, what was my scale factor? Number 5, scale factor for number 5. Oh, number 5. There we go. Jared? 2.5, yep. 2.5. If anybody has 5 halves, that's also correct. Notice it's bigger than 1. Figure got bigger. Oh, look at here. Somebody better what? Things getting smaller. So between 0 and 1. Do we have a scale factor between 0 and 1 for this one? Already heard from you, Jared. We're good to hear from somebody else. Dylan? 1/3. Yeah, 1/3. And honestly, guys, when I have you guys find the scale factor, it will probably be centered at the origin. Okay, the only time it won't be centered at the origin would probably be from yesterday, is find the new point. If it's not centered at the origin, we've got to use slope. But if I'm having you guys find the scale factor, probably be centered at the origin. And next up, describe what happened to go from ABC to A prime, B prime, C prime. Well, it got bigger, didn't it? And there's only one transformation we have out of the 4 we've talked about that something gets larger or smaller, and that is a... So describe the transformation that was performed. It's definitely a dilation. I don't think this was a rotation, reflection, translation. All right, but when we talked about those 3, we said, if you said rotation, you just can't say that word. You got to give me a degree measure. Well, dilation's the same thing. You just can't say the word dilation without giving me what the scale factor is. So that's on you guys right now to figure out, hey, what is the scale factor for this dilation here? Easiest way to do it is, all right, pick a Pick point A. What do we got there? Negative 2, 4. And its corresponding point, A prime, negative 5. I think that's 10. And just to be on the safe side, once you find that scale factor, I probably make sure it works for a B and B prime. All right, just to be on the safe side in case you made a mistake. So find the scale, find what you think is the scale factor, and then make sure it works on B and B prime as well. And we already know that scale factor should be less or bigger than 1. Should be bigger because A prime, B prime, C prime is getting bigger. So we're going to add to part A here in a second once somebody finds the scale factor. So it's a dilation with all right, what is that scale factor here? Hopefully bigger than 1 then. Hopefully bigger than 1. Jonathan, did you find that scale factor? 2.5. So dilation with scale factor, or you can put K equals 2.5. That's still not good enough. Anybody know what I'm missing? What I'm still looking for? Come on, we spent all yesterday. You need 2 things for the dilation. You need to know what the scale factor is and where the center is. And hey, if you ended up multiplying by 2.5 each time, multiplying by 2.5, where's your center have to be? Origin. All right, so scale factor 2.5 centered at 0, 0, or at the origin. Okay, got to give me both the scale factor and where the center is. All right, part B. Oh, we haven't seen that symbol in a while. What's that symbol there in between? Similar. Ooh. All right, we worked on congruent a couple days ago because distance and angle measures stay the same in rigid motions. Is a dilation a rigid motion? All right, so that term should not come into our answer here. You guys remember anything about similar triangles? Anything about similar triangles? We spent a whole unit on it. What? Go ahead, tell your classmates, Lauren. You're absolutely correct. Angles stay the same. Do angles stay the same when I dilate? Yeah, what doesn't stay the same? Side length. But angles do. Good job. Angles stay the same. So in our explain why, dilations. Remember when we wrote for congruent, we said rigid motions preserve distance and angle measure, but now we're just going to write dilations preserve. I don't want to write distance because you guys told me side length wasn't preserved. What is preserved? Angle measure. There you go. Dilations preserve angle measure. And what word are we going with today? Henceforth. All right, you got it. Henceforth. Or whatever you want to put. If you just want to put be thus and be non-creative, that's fine. Henceforth, triangle A prime, B prime, C prime. Similar. Don't put the congruent sign. The triangle ABC. All right. Just the sides aren't the same, but the angles stay the same. All right, we ready? You want to pick that bad boy up and hold it in your hand? It's been a while. Put the hand on top. Get the wrists loose. Whatever you need to do here. It's been a while. Like I said, I think it was Unit 5 last time we used the compass. Whew. Are we ready here? Drew, you ready? All right, it's been a while. All right, first one. Dilate triangle art The center's got to be at O and a scale factor of 1/2. All right, before we use the compass or straight edge, can we just have I want to make sure I'm explaining this well enough. What's about to happen? When we are done with this problem, what's this thing going to look like? Smaller. Perfect. Smaller. And what's going to happen to point A, R, and T? Further away from O or closer to O? Closer. All right, because the scale factor is less than 1. So we all envision a smaller triangle. A, R, and T are all going to get closer to O. All right, let's get A closer to O. Not just closer, how much closer? Half the distance, right? We're going to get A half the distance it is right now closer to O. So everyone, take your straight edge and connect A to O. All right, show me what the distance is from A to O. Connect A to O with your straight edge. So right now, we just drew in the distance from A to O. We just drew that in with our straight edge. And we want to do what with that distance? Cut it in half. Cut it in half. What am I looking for then? Oh, I'm looking for the midpoint of this, aren't I? You guys know how to do that. We just need a refresh. You guys know how to find the midpoint. You know how to do that construction. I take my compass. So what we're about to do is find the midpoint of AO, because that'll be halfway. Half is close. I don't know what happened last period. Look at this thing. I have no idea how that compass just grew on me. Looks like the guy on stilts here. I'm uncomfortable using something. All right, anyway, moving on. Put your compass point on one end point. You guys know what the deal is from here, right? Open it up.
A little more than half.
Whoa, a little more than half. Come on, Stella can get it. Let's go. All right, open it up more than half the length. And remember, you want like a half circle size arc working here now. All right, about a half circle size arc. Then you go to the other endpoint, either A or O, the other one, and make the same size arc. How many points of intersection do I need, though? Oh, there it is. I feel better. 2 points of intersection, correct. So I get 1 here, but I'm not stopping. I get 2. Do not pick up that straight edge yet. Let's just make sure we all are on the same spot here. Ooh, I can tell just by looking around. It's been a while since some of you used this, huh? We're looking rough. You might as well just put it in your mouth, some of you. It's going to look the same as your hand. Oof. All right, now let's grab our straight edge. But when you line up your straight edge with the 2 points, I don't need you to draw on that line. That's just going to be more of a mess. Because what do we just need to find? The midpoint. So line up your straight edge, but now I just want you to mark A prime, the midpoint. There's no need to draw the whole line in. It's just going to make more of a mess. More lines on your paper. That's not good news for us. All right, so you guys line up your straight edge. You're going to mark where it crosses AO, and that point's going to be A prime. You just moved A half the distance closer. And now we're going to do the same thing for, you guys are going to do the same thing for R and T. You're going to move R and T half the distance closer. So I'm going to let you guys go on your own. You guys decide what you're going to move now, T or O. Connect it with your straight edge first. And then find its midpoint. Get it halfway closer. I know T to O is going to be a little tough for some of you. That's a short distance to cut in half. Just take your time. We got plenty of time here today. when you line up your straight edge on the 2 points of intersection, remember, you don't need to draw the full line in. You just want to mark where the image is. At the end here, right, your triangle should be smaller and closer to O than the original one was in the previous. Smaller and closer to O. All right, we're all good. And look, guys, I'll be up front with you. I would only give you a scale factor of 1/2 if we're getting smaller. I wouldn't do a third or a fourth, or I'd do 1/2 for construction, and that's it. All right, let's get bigger now. All right, let's go to the next one. Let's get a little bigger. Now the scale factor's 2, but I threw in a little wrinkle here. Where's the center? Centered at B, which is a vertice. So guess where point B is going? Nowhere, right? If it's centered at B, B is not going anywhere. Oh boy, I'm going to make you dig deep. You're not allowed to look back in yesterday's notes. Point B is called what type of point then if it goes nowhere after I dilate it? Oh boy. Come on. It begins with an I. N. V. First thing we talked about in yesterday's notes. Invariant. There you go. Good job, Brennan. Good job. All right, so B's not, everyone's good. B's not going anywhere. Understand why? Because that's the center. So if you want to put right now, hey, comma, B prime, it's going to stay right there. The only 2 points that are going to move are A and C. How much further are they going to get away from B? Double the distance. Right now, A is a certain distance away from B. We're about to double it. Well, how do I double it? Well, let's extend side AB right now. Extend side AB, right? Because it's going to get further away from B on the same side, not on the other side of B. So let's extend this. Extend that side. Take your compass right now. Figure out that distance from A to B right now. Take your compass, open it up from A to B. So I measure the distance from A to B. And now I want to double it. Thoughts on how I can double it? Move it up, right? Move it up to point A. There you go. I just doubled it. It was from B to A. Now I'm going from point A. And I'm going to mark wherever A prime will be. I got further away, doubled that distance. There it is. There's A prime. the same thing for C now. Double the distance away that point C is. Measure the distance from B to C, then double it. And go ahead and use your straight edge to make the bigger triangle that's been dilated by 2. B stays right where it is because that was the center. Remains invariant. All right, last part. Are these two similar? Are these two similar? A, B, C, and A prime, B prime, C prime. Darn right they are. If it said congruent, I'd write no, but they are similar. Explain why. Because dilations do what? There we go. Preserve. Angle measure. Anybody have a good word here? I used that one already on Tuesday. What? Thus forth. Was that even an option? And it is now, right? We're combining both of them, thus and henceforth. Thus forth? I don't think so, but I'm writing it. Make sure we use the similar sign. I told you guys last construction that I probably only have 1/2 as the scale factor if we got smaller. Could I give you a scale factor of 3? Would you be comfortable with a scale factor of 3 instead of 2? Yeah. What's the only change up now? 1, 2. Now I go up here. All right. So yeah, I could give you something bigger than 2. Probably not bigger than 3. That's getting out of control. But all right. Some of you guys that might not have a compass at home might want to do the constructions right now on the homework to get them done. All right. If you don't have availability for a compass at home.